All right, so this is, which part is this? 3? Oh yeah, part 3. So now we're going to be looking at irreducible quadratic factors. And I know that these are distinct irreducible quadratic factors, meaning they're different irreducible quadratics, or prime quadratics. Is that what you would call them?
Yeah, that's what I call them. And I thought prime just meant I couldn't break it down.
Right. And then because these denominators are quadratic, their numerator expressions must be linear. Okay. So since you have taught me so well over the course of this series, we're going to do it your way.
Okay.
So we have 3x squared plus 6 is equal to ax plus b times it needs the x squared plus 4. And then cx plus d needs the x squared plus 1. Oh, oops. Let's slide this over. All right. So this is where you're going to have to plug in some numbers, and that, like that one problem where we did those radicals.
Mm-hmm.
So I'm pretty sure you can do the same thing with the roots of these irreducible quadratics, like with complex numbers. Yeah. So I'm going to choose, I'm going to plug in x equals positive I.
Okay.
That's going to be I squared's negative 1. So on the left-hand side, it's 6 minus 3, which is a 3. And then this one is going to get canceled out on the right-hand side. And then all that's left is this one. So you have I squared negative 1. So 4 minus 1 is going to be 3.
Yep.
And so you'll have that constant 3 times this AI plus B.
Yep.
And then you can divide both sides by 3, so you really just have 1.
Okay.
Okay.
Then we're going to plug in negative I?
Plug in negative I. So then you'll have the same thing. This is going to be a 3.
Right.
And then when you plug it in over here, it's going to be the same thing. So it's going to end up being 1 equals negative AI plus B. And then when you add them together, you'll get 2 equals 2B. To be or not to be. And then you'll just get b equals 1.
Okay.
Yep. And so since you know b is equal to 1, it doesn't matter which one you go to. You have 1 equals ai plus 1. And I look at this, say, well, for this to be a true statement, you got to cancel out that term. So a has to be 0.
Yep.
So we found a and we found b. So then we're going to do the same thing with the roots of x squared plus 4. You'll plug in plus and minus 2i. So x equals 2i on the left-hand side. So it's going to be negative 4 when you plug it in square it, right?
Right.
So negative 4 times 3 is a negative 12. So you get a negative 6.
Right.
And then you'll end up having a equals minus 2c, or positive 2ic, say 2i times c. And then you have the plus d. And then it's constant when you plug it in over here. That's going to be a negative 3.
Yeah.
So then you divide both sides, you get a positive 2. So you have the positive 2ic plus d.
Yeah. And the other one is just the negative 2.
And the other one's going to be the negative 2i.
Yeah.
So when you add them together, you get 4 equals 2d. So d is equal to 2. And then when I come back up here, if d is equal to 2, you have 2 equals 2i times c plus 2. Oh, ran out of room. Right underneath. Well, I have a 2 on both sides, so this tells me c has to be 0.
Yep.
So your result would be the b value is a 1, so 1 over, I can't remember which one I did first. Was it the plus 1? And then, it's x, not s. Stupid Laplace transforms. They're actually really cool. Yeah.
Yeah, 1 and 4.
All right. So, what do you think about that?
That's great. Well, we were talking, what was it, earlier this week about plugging in I values and made my head hurt. That actually kind of makes sense. So I guess I can't be too mad at it. I don't think I ever would have thought that.
Well, I think the only time you might have a little bit of an issue is if you had like a cubic on the left-hand side, because you'd have I cubed. So maybe you'd want to use some different numbers
Right.
or something. But when you've got just like x squared, that's easy to plug in.
Right.
So
Cool.
I think so.
Yeah, I think that is pretty cool.
It was fun watching it yesterday. I was so tempted to be like, what number do you guys want to plug in? 3i! 49!
Goodness gracious.
Well, hopefully you were able to learn some things in this video.
Yeah, I know I did. Let us know.
I think this is kind of cool.
Yeah, I was gonna say, let us know in the comments if you learned something.
Yeah, and if there's something that you'd like us to do with partial fractions, let us know. Let us know in the comments. Fill out those submission forms. Send us problems. We're still bored. So, thanks for finally making it through part 3. Thank you for watching. And hopefully you're having a wonderful time with the two of us.
All right, we'll see you next time.
Adios.